Welcome to the next video discussing the new options and extraction routines in n4ce 4.3. Today we're going to look at extracting catenary or cables in essence. Before we've been looking at extracting white lining and tops and bottoms of objects, basically looking for height change. Today we're going to be extracting cables. So to start that, I'm going to go to the cable extraction option. I've got some test data here. I've actually already sort of segmented it using other tools. Basically, I've already found the track and then basically grouped distance from the regrouped the data based on distance from the track. So I can, if I want to, I can turn the track and the banks off and just leave the catenary data in there, which I'm going to do because obviously it's going to make it easier to see what we're doing and pick them in a minute. So with the white lining, the metric was the intensity. With curbs and crash barriers, the metric was height change. Here, the metric is basically data. There has to be some data to munch down. So if you remember back to the first video, I essentially said that this algorithm is basically like a caterpillar taking chunks, and you blindfolded it, and it can only go basically where you allow it to based on the constraints of the algorithms. So with a cable, there's nothing around the cable, so it's going to follow the data wherever the data goes. And the other good thing about cables is that they generally hang in a straight line. You can't get a bend in a cable if it's taut at both ends and hanging free, so that makes it a little bit easier to actually extract cables than anything else, because there shouldn't be any other data around it, and they basically essentially go in straight lines. So let's start then by creating ourselves a new preset. It goes without saying that once you've got your presets up and running, okay, even though you saving them saves them to the project, it doesn't actually save them to a disk. Well, it does save them to disk, but it saves them to the current project to actually create an external file that you can then keep referring back to. You can use the export option there, and that will actually allow us to create a file that we can actually then share with somebody else. Okay, so output point spacing, how often do you want to point? Let's say every meter for argument's sake. Clustering, don't need to worry about that because it's clean data. This is actually one situation though where clustering may be needed. If there's gaps in this track data in the OLE, if there's chunks that are missing for whatever reason, then the clustering is what's used to actually glue them back together again. But this data is actually fairly clean, so I don't need to worry about that. Max distance, so this data is actually quite big, it goes on and on and on. If you want to actually only work in certain segments, then maximum distance, say put it in there at 500 meters, and it'll only work, it'll stop after pulling out half a K. Redirects, so again with redirects, this shouldn't be too bad. You shouldn't need too many redirects. I'm going to start that out at around 5. Redirect length, so redirect length you've got to be a little bit careful of, because if the redirect length is too long, it'll jump cables if there's cables around, because essentially it'll get to a point and then there won't be anything ahead of it, and it might leap onto another cable if there's a lot of cables close to each other. So you've got to be careful with these. DZ toll, how much height change are we looking at? That's obviously proportional to the length that we're going to extract. 0.1 of a meter over 2 meters probably will work quite well, so we'll leave that as is. Horizontal tolerances, again, unless this thing's moving around in the wind between repeated scans, we shouldn't need to go too far left and too far right, so I'll leave that on 50 mil. Not worrying about diesel change per meter. Search distance, so it's working 2 meter chunks. That should be okay. Not worrying about the fine adjust stuff. We will reduce everything to a regular grid so that, I mean, on this data, I think this is mobile mapping data, it won't make a difference so much, but if you've got lots of static scans and they all overlap, you can end up again with quite pronounced density peaks in places. which would slow it down if this wasn't in place. Douglas worker, 5 mils good. As I said before, because cables tend to hang in a straight line, we can actually up this coefficient, so we don't have to be quite so relaxed as we were with road markings and curbs and whatnot. And let's, yeah, for 50 mil should be okay as well in the max standard deviation. If it's not, obviously we're going to change it in a minute. Mean height over length. So again, because the data isn't too bad, I'm not going to. Sorry. If the data like this moves around, the height needs to be smoothed out over a longer distance. So I'm going to say 0.5 in there. Otherwise, you can end up with the next sort of guess shooting up and shooting down, because the point data is quite noisy within the bounds of the actual cable itself. If that makes any sense. That's okay. Right, so I'm just going to drop the seeds on now. So I'm going to start by doing the cables that are hanging along the top, and you can actually hold shift down as you do this. I'll do that, and then it should just let me just now add another one without actually having to go add. So it goes from there to there, from there to there, and from there, and I can add. If you scroll to the top, you'll actually see this option here has become active, and you can now change whether it's picking nearest or farthest. Obviously, if we're picking cables, you want it set to nearest in case there was anything behind it. That was just another reason for me turning off the track, so it just obviously makes the picking of the seeds easier. Okay, so I've got 1, 2, 3, 4, 5, 6 seeds. Try extract, see what happens. Okay, so how do we do? So first seed stopped there. Okay, we can probably get that to carry on if we were to increase the horizontal search distance. We should be able to do something there. So that was the first one. Go to the second one. Second one stopped because the data stopped, which is pretty good. Third. Okay, so that's stopped in the tunnel. Maybe because the redirect didn't quite do its job. There is some data ahead of it, I can see there. So we'll tweak some settings, I think. Seed 4, that did its job, stopped properly. Seed 5. Seed 5 stopped because the data stopped. Seed 6. And it stopped because the data stopped, pretty much. So, what can we do? I'm going to tweak the settings because I think we can improve these a little bit, and maybe get it to go through the bridge properly on that other channel. So I'm going to hit reset. Don't really need to spin it around, but might as well. And then let's have a look at these settings. So let's go look here. So I'm going to widen the horizontal search to try and help it pick up cables that go off at a bit of an angle from where it was originally looking. Okay, so I'm going to drop down the redirect. Make that a meter. I'm a bit worried about it jumping across to other cables. Horizontal tolerance I'll keep as is. That's actually for afterwards, but that might trim out data that I want, so I'm going to put that down to about 2. That's fine, keeping height over length. I'm going to increase this value here for the standard deviation so that it lets data, again, a little bit further away from the ideal through. And that should help it, again, latch onto cables that shoot off at other angles. And extract. Okay, so that stopped where the data stopped. So is those two. Let's get 4, 3. That stopped. Okay. 4. 5. 9, 16. So what looks like happened is 4 and 5 have actually touched somewhere. So we need to go and sort that out. 6 has finished where it can, where it basically needs to finish. So 4 and 5 we need to check out. Okay, so what's happened is the 4th one has actually jumped on top of the other one. So what I'm going to do is I'm going to try and drop the DZ toll and re-extract. Okay, yep, so this one is now so first one has stopped where it should do, second one has stopped where it should do, third one has stopped where it should do, fourth one now stops where it should do, and it no longer jumps across, which is good. Fifth one is on its own, and the sixth one again has stopped where it should do. Perfect. When we are pulling out data, you can tell it to prefer high points or low points. So if I was to untick that, it goes blue. And what that means is it will actually prefer, put it back on high. So when it comes to a crossing, so if I go back to this 4th point here that's finishing here, where we have the situation where they cross like this. Okay, so I managed to get it to ignore this top cable by reducing this DZ tolerance. So essentially it didn't consider the data above. Where you do have 2 cables like this, it's often, or it can be, you can get round it, like I said, by, if you know it's going to do that, if you're having problems with it, what you can do is you can actually right-click the seed and say, don't use the high points, and essentially what it'll go blue, and what happens then is, so see it's gone blue, what happens is then, even though that DZ toll may actually include the data above when it hits another cable, across another cable, the algorithm will naturally prefer the lower data. So that would be another way of getting it to go through. There's also an extract catenary option. That will essentially, once it's finished doing this first stage, it'll go back through the data and try and fit more, so shall we say, mathematically precise catenary curves. And it kind of blends between a polynomial and an exact catenary curve, which is hanging due to gravity. I wouldn't advise you use that at the moment unless the data is only being supported like it is here If it goes through a bridge or something like that, that will break down the algorithm because it's not expecting it to suddenly shorten. And when we release this finally as a proper release candidate, the catenary will actually be a second option. So you can actually say click a cable between 2 points and then fit the catenary automatically. It's a little bit hit and miss if you let it do it just willy-nilly. So those have been extracted, or rather they've been run. They haven't been extracted yet. So to extract them, I'm going to put a code in here, and I'll put in the code CW for catenary wire, although they're obviously different wires. I know that will probably annoy some people. And I'll do commit all. Now, to show that, I'm just going to bring the data over. Okay, so I click always visible, and then just temporarily turn off the point cloud. There's all the data that's been extracted. Okay, so let's turn the point cloud back on, and we'll pull out the lower cables. So I'm going to clear the seeds and add. So put that one in. Put that one in. So I'm holding down Shift as I do this, so I don't have to keep going back to the button to do it. So all the same settings as before. And what I'm going to do this time is right click each one and untick use high, because we want these to be the lowest points. That all done, hit extract. Okay, so that's gone to there, which is good because that's where the data finished. Second seed, finish where the data did. Third seed, finish there. Fourth, finish there. I'm going to change the code. I'm just going to use arbitrary codes that draw different color lines that I've already set up. Okay, so I've extracted those now. I turn off the point cloud. There's our cables. Clear the seeds. And then if I look in the modeler, here's the data. I've turned off the points. Here's the data. I just do a quick feature section. There you go. And that concludes our cable extraction video.